Okay, this is our last section in Chapter 7 on polynomial operations with multiplication division. And the last section, 7.3, is division of polynomials by monomials. And the first question says, I need to use, actually we'll go back one question first. I'll do this one right here. So the show you know gives you two questions. We're only going to do the first one. We're not going to do this one here. We're just going to do one. And I'm going to show you three methods you can use to determine the quotient or the answer to a division using three different methods. The first method is what we call an area model. And the area model, if we talk about, and I'm going to use a simpler one now. If I said the area is 12 meters squared and the length is 6 meters, what's this length here? What we would say is, well, if I took my area and divided it by my length, that will equal my width. And algebraically, I think area equals length times width. If I was to divide both sides by length, excuse me, I would end up with width, it's isolated. And over here, I'd have area divided by length. So, knowing that, we would be able to then calculate on the simpler one that the missing dimension is 2 meters. Okay, because 12 divided by 6 equals 2. So using the simpler idea of a simple rectangle with simple measurements, the same idea can be stated when we have more complicated ones, like the area is 15x squared and a negative 12x and a width of 3x. The only difference is what we're going to do is we're going to break it up. The rectangle's area is going to be broken up into two separate little mini rectangles. The first one being this one here, and the second one, of course, being the one that has an area of negative 12x. So 3x multiplied by what gives us an area of 15x squared? The answer is 5x. 3x times 5x is 15x squared. And 3x times what gives us an area of negative 12x? It's negative 4. So therefore, 15x squared minus 12x divided by 3x will equal 5x minus 4. That's using the area model to solve it, okay? The other one we can use is an algebra model, algebra tile. Algebra tile, there we go. That's close enough, you get the idea. Algebra tile. I can't have that. It looks like the tile. And what we're going to do is we're still going to have our length and our width. But this time, instead of representing the width with the numbers 3x, or the coefficient of 3 and the variable x, I'm going to actually draw 3 x tiles here. An x tile, an x tile, and an x tile. And inside here, oh, that's a lot. I'll send just a bit here. I'm going to draw 15x squareds. Oh, heavens, this is too much work. So we need to fit, so now we have our 15x squareds all here. This is x squared, etc. And over here, we have to figure out how to fit 12 x's. So I'm going to cut these into the there. That should be good. So now we have our negative x's. I'm not going to shade those in because those are negative. I'm going to ask myself, well, what has to go in the top part to represent this area? So 3x multiplied by the missing length gave me the area right here. So this has to be a positive x, a positive x, a positive x, a positive x, and a positive x. Because a positive x times a positive x equals an x squared, so I'm going to shade those in positive. And all of these here, because these are negative x's, these are all negative 1s. Those are all negative 1s because x multiplied by negative 1 equals negative x. Ooh, try that again. X, which is this length here, multiplied by negative 1 equals the tile that I'm using, which is an area tile of negative x. So my last step is then interpret, well, what is this drawing that I did up here? It is 5x minus 1, 2, 3, 4, 5, 6 minus 6, which I screwed up on it somehow. Oh, that's why. Oh, minus 12. I drew too many. Haha. Minus 4. Minus 12x. I screwed up again. Where did I screw up? Oh, it's minus 4. That's right. So up here, I'm not recording? Oh, I am recording. Hello. It's minus 4. There we go. Anyway, well, I screwed that one up good, but I can't go back, so it's too late. And the last one we're going to solve with is using distributive property. So 15x squared minus 12x divided by 3x. So just like in the last section where we used multiplication by a monomial by a polynomial, when you divide a polynomial, so what we're going to do is we're going to divide the polynomial by 3x. And just like if we had this one here, we would multiply every term in the polynomial by 2. When we divide, we're going to divide every term in the polynomial by 3x in this one. So I'm going to take 15x squared, and I'm going to divide it by 3x. And I'm going to take negative 12x, and I'm going to divide it by 3x. Some people forget to attach the negative sign to the term, and they end up getting the wrong answer. So make sure you do that. So 15x squared is really 15 multiplied by x multiplied by x. And 3x is really 3 multiplied by x. If we reduce this to lowest terms, 15 over 3 will reduce to 5 over 1. And x over x will reduce to 1 over 1. And when I now multiply out what I have, 5 times 1 times x is going to be 5x. And 1 times 1 is simply 1. So therefore, 5x over 1 is not necessary to write the over 1. And this will reduce down to 5x. Negative 12 times x over 3 times x. The negative 12 over 3 will reduce down to negative 4 over 1. The x over x will reduce to 1 over 1. Negative 4 times 1 is negative 4. 1 times 1 doesn't exist anymore. It's just a 1 denominator. So I end up with that as my solution. So that's the show you know. That's the gist of what we have to do for this one. And the first question that we're going to do is question 2. It says, Anita used the following method to simplify the expression. Is she correct? So here she has 9k squared divided by 3. I'll move it over here. And the first thing she did was she rewrote it as 9k squared. So far, everything she's done is fine. She took 9k squared, she's divided by 3, and she has a 3k, she's divided by 3. The only thing I would say differently that she should do, that she doesn't have to, but I would have just put it up here, right? Makes it easier for me. So 9k squared divided by 3 is going to be 3k squared, and negative 3k divided by 3 is going to be a negative k. And if we look at what she put, she divided these two, and instead of canceling out the coefficients to get the 1, she canceled out the coefficients to get 1 and the variables. So she should have left a k there, and she didn't. So Anita's a baloney head. Question 4, what division statements are represented by the algebra tiles determine the quotient? So here, since this is an x, and this is an x squared, this has to be an x here, this has to be an x here, this has to be an x here, and a plus 1, and a plus 1. So therefore, the solution would be 3x plus 2. The entire division statement would be 6x squared plus 4x divided by 2x equals this. Question B, the division statement would be 4x squared plus 6x, which is my area, divided by the length, which I know, which is 2x, will equal 2x plus 3. And C, the final one, the area divided by, so really what we're doing here, just to rephrase, area divided by the length equals the width, or You can say area divided by width equals the length. It doesn't matter. So the area here is what's inside, which is 6x squared minus 3x, divided by the length, which is the monomial 3x, will equal what's missing. These will be positive x's. This will be a negative 1. So it equals 2x minus 1. Divide each expression using a model. So for these ones, I'm going to use the area model. I just like it better. It's easier to do. So this is going to be a 5x squared and a minus 10x. And the width is 5x. 5x times what is 5x squared? The answer is x. 5x times what is negative 10x? The answer is negative 2. So therefore, the answer is x minus 2. Here, using the same area model, area of this square or part of the rectangle is 4x squared. This is 12x. This is 2x. 2x times what is 4x squared? 2x times 2x is 4x squared. Conversely, you could have said 4x squared divided by 2x is 2x. Or 12x divided by 2x is 6. You could also go backwards. Either way, you end up with a solution of 2x plus 6. So notice there is no symbol in here. Since we know it's a positive 6, it's going to end up being the connector of my binomial. It's a positive 6 or a plus 6. Question 8, divide. Since it doesn't say which method, I'm assuming everybody will use distributive property. So I'm going to write the first thought out. So every one of these terms is going to be divided by 2y. So 2y squared divided by 2y is the first thing I think about. And a 4.2y divided by 2y is the second thing. When I do this, I end up with y. When I do this, I get 2.1 or a positive 2.1. So the solution is y plus 2.1. All right, that's taken care of. The second one, we have this is going to be divided by 2, this is going to be divided by 2, and this is going to be divided by 2. So I'll rewrite this one out. So 12m squared divided by 2. Now remember, this is a negative sign, so let it stay with your term. Divided by 2, and 24 divided by 2. When you divide each of these by 2, you're going to end up with 6m squared minus 3.1m and plus 12 or positive 12. Squeeze those all together. You end up with a solution of 6m squared minus 3.1 plus 12. Now, sometimes people didn't include that, so they have this instead. To make sure, because it's a positive 12, you use it as your addition sign in your trinomial. Let's try and do C without doing the rewrite. I'm going to just, in my head, do this and see if I can do it. So negative 18y squared divided by negative 6y. Well, negative 18 divided by negative 6 is a positive 3. And y squared divided by y is y. So the first answer for the first arrow is 3y. And then negative 6y divided by negative 6y is really easy because any number divided by itself is 1. And a negative divided by negative is a positive, so the answer is going to be a positive 1. And that's the solution for C. And finally, D, I'm going to rewrite this one. Negative CV divided by 3C. I'm going to divide the first term and then the second term. Negative 2.7C divided by 3C. So 3 and 3 make 1 and 1. C and C make 1 and 1. So 1 times 1 times V is simply V. Negative 2.7 divided by 3 is negative 0.9. And C by C cancel each other, right? So your solution for the last one is V minus 0.9. Oh, as if we haven't talked enough about dumps lately. A dump truck holds 10 cubic meters of soil. You are filling a rectangular space in a yard with dimensions of 2x plus 3 plus 5x by 5x by 2. What polynomial expression represents the number of truckloads of soil we need? So I'm going to draw my truck first. I have to admit something. When I first did this question, I misinterpreted what it said. So if I drew the yard, I'm just going to make a... This is the yard. a three-dimensional rendering of the yard that needs to be filled with soil. The length of it's going to be 2x plus 3. The width is going to be 5x. And the height is going to be 2. So if I think about volume, volume is area of the base times the height of the prism, or area of the base meaning 5x multiplied by 2x plus 3 multiplied by the height, which is 2. And that will be the volume. Now, if I think of an easier one, let's say the dimensions were not this, but instead I'll do it in red. Let's pretend it was 10, 4, and 3. Then I would do 10 times 4 for the base, and I would get 40. And then I would multiply it by 3 to get 120. Right? That's how I would do it if they were simpler numbers. But in this one, we have polynomials. So the first time when I multiply, I have to use distributive property on that first to get the area of the base. And 5x times 2x is 10x squared plus 15x. And what that represents is the area of the base. And I'm going to keep that in brackets, and I'm going to multiply it by 2. Now, some people get confused here because you have a polynomial multiplied by 2 and the monomial is second, and they like to see it first. But you still have to use distributive property to multiply the binomial by 2. And when you do so, you're going to get a final area, or volume, excuse me, of 20x squared plus 30x. That is the volume of this particular yard. And that's cubic meters. Okay, we don't know what x represents, so it's a polynomial that represents the volume of that yard. And since every truckload can do 10 cubic meters, we are going to take that and divide it by 10 to see how many truckloads of dirt are needed to fill this. And what all we're going to do here is divide that polynomial by 10. And in doing so, 20x squared divided by 10 is 2x squared. 30x divided by 10 is 3x. And therefore, it will require 2x squared plus 3x truckloads of dirt to be able to fill up that yard. I know it sounds complicated because that doesn't even make sense, but that's the answer. Now your next one, question 11, says a rectangular fish tank has the dimensions shown in meters, and its volume is represented by the polynomial 7.5w squared minus 3w. What polynomial expression represents the base of the tank? Now here's what's interesting. So in my opinion, this is much easier to think of it this way. And we could do it a number of ways. I like to reorientate it. And I tell you why. Because I like to have my base as being w and 0.6, and the height I don't know. And here's why. If the volume of the tank equals the area of the base times the height of the prism, then if I divided both sides by the area of the base, algebraically speaking, whatever you do to one side of an equation, if you do the other, you keep it equal. So area of the base divided by the area of the base is like canceling out two coefficients that don't exist. And what I end up with is the volume divided by the area of the base will tell me this mystery height or this length, whatever you want to think of it as. Okay? So since the volume given was this polynomial, and the area of the base is going to be this times this, 0.6 times w is simply a coefficient of 0.6 w. I can't multiply them together beyond that. It's a coefficient and a variable, and that's what it ends up being. So the volume divided by the area of the base will equal this missing dimension right here. And all I have to do is simplify it using distributive property. So 0.6 w divided by 7.5 w squared and 0.6 w, 3w, whatever. You get the idea. So I'm going to rewrite it. First one I'm going to do. And the second one I'm going to do. 7.5w. 7.5 divided by 0.6 equals 12.5. And w squared divided by w is w. Negative 3 divided by 0.6 is 5, but negative 3 divided by 0.6 equals 5. So minus 5. W and w cancel each other out. So therefore, in a convoluted way, that is the missing dimension of the tank. This one's easy. A rectangle has an area of 9x squared minus 3x square units. The width of the rectangle is 3x. What's the length? So area divided by length equals width, or 9x squared minus 3x divided by the one I know will be 3x minus 1. So therefore the missing dimension is 3x minus 1. I know, I'm too tired to do this one. We'll skip this one. We'll go on to this one. Question 15, it just gives you three fairly convoluted looking polynomials, divisions. But remember, it's simply just write it out. Let's see if you can do it this way. So, and then 0.93 g divided by 0.3 g. First one is, what is 3.6 divided by 0.3? 3.6 divided by 0.3 is 12. So that cancels those two out to give 12. G divided by G is 1 over 1, which is 1. F stays with F. 0.93 divided by 3 is 33, but 0.93 divided by 0.3 equals 3.1. And G divided by G cancel each other out. This is a positive, so therefore your answer to 15A is 12F plus 3.1. 12F plus 3.1. Your second one, oh, this is a lot of work. So 2/3 b squared divided by 1/3 b. Negative 1/3 ab divided by 1/3 b. And 1/3 b divided by 1/3 b, well, that's the easiest one of the whole bunch because any number divided by itself is 1, but we'll get back to that. So here we have to divide coefficients. So I'm going to go down here and say, what's 2/3 divided by 1/3? And I'm going to use my fraction sense to solve this. Keep your first fraction, change it to multiplication, and use the reciprocal. Right? That's how you divide fractions. Since you're multiplying fractions now, you can cross-reduce. And when you do so, 2/3 divided by 1/3 is simply 2. 2/3 divided into groups of 1/3 gives you 2 groups. B squared divided by b is simply b. 1/3 divided by itself is 1, but don't forget it's a negative divided by a positive. So it's a negative 1a, and since we don't need coefficients of 1, we'll erase it and just consider it a negative 1a or negative a. And any number divided by itself will be 1, and since it's a positive divided by a positive, it'll be a plus 1. So the whole solution of what looked to be incredibly convoluted ended up being not that difficult. By working it all out, you end up with the expression, the solution, the quotient. So if I can grab this, there we go, of 2b minus a plus 1. And finally, your last question, negative 4.8x squared divided by 0.2, positive 3.6x divided by 0.2, and negative 0.4 divided by 0.2. 4.8 divided by 0.2 is 24. Will it be a negative 24 or a positive 24? It'll be a negative 24. And x squared has nothing to cancel it out with, so it just ends up staying as an x squared. 3 points. So the next term, 3x divided by 0.2 is going to be, what did we say it was? I pressed pause in the video, now I've lost my train of thought. So it's 3.6 divided by 0.2, which was 18. So plus 18x minus 2, because 0.4 divided by 0.2 is 2. And that's your solution for the last question.